How many of you have heard of certificate pinning or have been doing certificate pinning in their applications? All right, that's very good. So this talk is about developers that want to or thinking about implementing certificate pinning in their applications and some of the considerations they need to make and some of the decisions they need to make. So I'm John Kozyrakis. I am a security consultant for the last more than 6 years, and most of them in digital. I'm based in London, UK, previously European country. I do mostly mobile security. I work with security architects in designing security features in mobile applications. And I also do a lot of like work in static analysis of Android applications and building automation tooling for assessing them and all that. So we're going to go through what trust means for a mobile application, what is certificate pinning, some fundamentals, some decision points, then common flaws, bugs, and mistaken things that developers have, we've seen developers doing, and some advanced topics if we have time at the end. This presentation will be published, of course, in the OWASP website, and there's also going to be an ebook type thing published, and I'm also working in updating the OWASP wiki page for certificate pinning. So, how can a client trust a server? And that's a very big question. And the idea is that you have to bind, the only thing that the server can send to a client is a public key, basically. And you have to have a way to bind an identity to that public key. One way to do that is certificate authorities. Certificate authorities testify that this public key belongs to this identity. And because you trust the certificate authorities, you trust this certification. An alternative is pinning, because pinning itself can do this binding. So you can set up your application in such a way that you know that this identity belongs to this public key without certificate authorities. And then there are hybrid approaches where you do both things at the same time. A brief overview of X509. So certificates, servers have certificates, and those are the basic, the most important fields that certificates have. There's the subject field, which is usually the DNS name of the endpoint. There's the public key of the server, and then there's the signature that binds those two things together. And the way this whole thing works is through a certificate chain. So what really happens is that your operating system trusts a lot of certificates, a lot of certificate authorities, and then it builds a chain of trust between the certificate authority it trusts and the endpoint of the certificate that was presented by the system. So it is important to know that the client does that. The client builds that chain, and it goes from the end entity certificate. End entity is the official name of like what we call a leaf certificate or endpoint certificate, the host that we are communicating to. And it builds a certificate chain from the end entity to the trusted anchor that it trusts. And then it checks all the fields in every certificate to make sure they are valid, the signatures are valid, and then it does TLS-specific checks, like it's basically the DNS name that it wanted to contact is the same as the certificate of the endpoint that like the chain ends to. However, and this is, like in this talk, we are going to focus mostly on mobile applications because that's where we see certificate pinning used in most times. Mobile applications have this special property where they know their endpoints in advance. So most mobile applications, they communicate with 1 or 2 or 3 like REST endpoints. The developers know what endpoints they are. They don't need a certificate authority to testify that those are the endpoints. They know in advance. So like browsers and mobile applications are like different because on browsers, the browser doesn't know what he's going to contact, but mobile application mostly does. Maybe it doesn't know everything. It doesn't know like all the advertisement libraries. It doesn't know all the analytics libraries, but it knows the critical, the sensitive endpoints. So as we said, the goal is to associate the identity with the public key, and that association to be owned by the developers and not the certificate authorities. So you can really narrow down on what you trust. So the most important thing is what are the benefits over normal TLS validation? Because pinning is basically a defensive depth approach. We have seen time after time again the last years or more that there are rogue certificate authorities. They get compromised. They issue certificates that they shouldn't be issuing. And there are even attacks where users are fished into inserting certificates, malicious certificates into their trust stores. So you end up not knowing what to trust. And maybe that is not good enough for some enterprises, like in financial sector, for example. The OWASP webpage maintains a list of articles that describe such attacks. I'm not going to go into details on all this, but it's quite a big list. And the other thing that you have to take notice is that you have to have a reduction of the attack surface. Your operating system trusts a lot of things. You'll be surprised how many certificate authorities it trusts. More than 200 in the normal case. And those certificate authorities, they include governments that you never wanted to trust, or there includes three-letter agencies or whatever, companies that are suspicious and you don't really want to trust. It even includes intermediate certificates for companies that make man-in-the-middle appliances, which is questionable. This is from a recent paper. It's the number of certificates that are included in operating systems, the number of certificate authority certificates, which is kind of surprising. So do you really need to trust all that? That's the question. That's the question you as developers and security architects need to answer for your applications. There's not one answer. It doesn't fit everyone. So if you are concerned about malicious issued certificates and attacks where an attacker has a CA certificate in order to man-in-the-middle your traffic, then you should do pinning. If you are thinking about it, then pinning is a defensive depth approach, but you should really take care of, you have to understand if you can manage the complexity, because it's not easy. If these attacks are not for you, and you think that you don't really care if you get attacked by NSA or something, then pinning is not for you. And it's really not worth the effort. There are downsides. This is a very, very basic misconception that people have. Pinning will not protect the connection if the pinned certificate is compromised. The whole point about pinning is protecting the connection if anything else in the ecosystem is compromised, not the thing that you have pinned to. So this is a very basic thing you have to remember. It will create a single point of failure. It will probably cause your application to be unreachable by your users if you get it wrong. So it creates a lot of headaches operationally, and you have to be mature enough to manage them. And also, it may impact the performance of your mobile applications, because there is one extra check, and there are slight implications there, like usually pinning checks are done, they are blocking checks, so your performance is going to take a hit if you depend on asynchronous loading of various things. Also very important, pinning will not stop local attacks. And this is, we've seen it all around, and people have this misconception. So if a device is jailbroken, if a device is rooted, if there is a substrate or some hooking framework on the device, if users insert their own certificates, things like that, or reverse engineers see the traffic, pinning is not supposed to protect against those attacks. Pinning is not a control that is going to stop your traffic from being visible to someone that wants to see. It protects against a very specific set of attacks that have to do with attackers on the network having certificate authority certificates that they shouldn't have. So if your goal is to protect on jailbroken devices, for example, then you should really think about doing hardening and obfuscation, or going to the native layer, or doing other things like client-side controls and raising the bar, but it's all client-side controls. They can be fundamentally eventually bypassed. So that's an attack that is not considered in the pinning threat model. Also, and we see this in penetration test reports that our clients get all the time, absence of pinning is not a vulnerability. like you are not vulnerable by not having pinning. If you do SSL correctly and you do HTTPS correctly, like pinning is an add-on, it's like an extra control. It may be a good practice for some applications that really care about pinning and those kinds of attacks. It's not like something that we put like in penetration testing reports for going to everyone. Like not everyone needs to go to do pinning. However, if you do pinning and you have a pinning implementation, if it's broken, then that is a vulnerability, because that allows an attacker that you want to keep out to get into your application. So that breaks your threat model, basically. So that is a vulnerability. So say that you like certificate pinning for some reason, and you want to implement it. You really have to think about a lot of things. And these are just some of the very basic questions that you need to answer, and you have to create like a document that describes like an architectural solution that describes what you are planning to do. So the first one is, where do you pin to? You have basically three options. Like all certificate chains have basically three steps, or maybe more intermediates in there, but they have like an end entity and like one or more intermediate CAs and the root CA. And your decision is basically which one are you going to pin to, or multiple. The most secure approach is to pin to the end entity certificate. So that is the certificate of the host, the certificate of the server itself. This is the tiniest attack surface possible, because your connection will only be able to be compromised if your host, and just your host, is compromised. If anything else is compromised in the whole ecosystem, the connection is not is still secure if you've done it properly. And it's so secure that you don't even need to rely on third parties. You don't even need to, like this certificate can easily be self-signed, doesn't matter. Like if you pin to the entity certificate, doesn't matter if there's a CA signing it or not. You only trust that specific public key. And if you manage to open a session, an SSL session to a server with that specific key, you know that the server holds the private key. So there is no more to that. You don't even need to validate any chains or anything else. There are problems with this approach, and the biggest one is that it's very fragile. And it's very fragile because end-ended certificates rotate all the time. They change all the time for various reasons. If you were in the keynote this morning, you heard Mike say that they are also pushing for having shorter lifetimes in certificates, less than 90 days, so that they get rotated. And that is a problem if you want to pin to them. Another option is intermediate, pinning to the intermediate certificate authority. This allows you some flexibility because you don't need to update your pins all the time. It exposes your implementation to any chain validation bugs that may exist. There are problems with this approach, and there are serious problems. And the problems is that intermediate certificate authorities change. So say that you have a certificate from VeriSign. This certificate from VeriSign is signed by, like VeriSign signs an intermediate certificate authority, and thus the intermediate certificate authority signs your certificate. When you rotate the certificate and you get a new one, there are no guarantees that the same intermediate certificate authority is going to sign your new certificate. You only know that VeriSign is going to sign it, not the intermediate. So like in order to manage that, basically every time you rotate, you need to check your pins. But this is the very thing that you were trying to avoid by doing the intermediate certificate pinning. So it gets more complex. And there are also cases where one intermediate may have multiple certificates, and like it gets very complex. So we move up the chain and we go to the root CA certificate, the root CA identity. If we pin to that, it's very flexible because you don't really need to pay attention too much on when you rotate certificates. It's going to be signed by like Komodo all the time, as long as you keep Komodo. The problem is that you start going backwards, and while your original goal was to trust only your server, now you trust only a certificate authority. That is a good balance for most actually. There are some implications about some tricky parts about cross-certified routes, and you have to make sure that the CA that you pin to is present on all your clients, which may not be the case. And you open yourself up to chain validation bugs, and we're going to talk about those later on. But it is a good balance. You only have to consider that if anyone compromises any intermediate certificate authority that your CA signs, then your connection may be able to be compromised. There is one alternative, and it's an interesting one. There are a lot of organizations that have their own internal certificate authorities, and they use those internal certificate authorities to provision certificates for their servers. And if your organization does that, then it's a very good idea to pin to that certificate authority. Because if you do that, then you don't need to update your pins all the time, and you have full control over what your internal certificate authority provisions and signs. So you have a degree of trust over what is going on. So it's a secure and flexible approach. There are some possible issues with compliance. So if you get audited for some reason and some auditor says that, this host has a certificate chain, but it's not public, it's not signed by a public certificate authority, like there's a big X when I access it through Internet Explorer. Well, you have to have a discussion with him at that point. It's not easy. And of course, no client will be able to access that endpoint unless it uses your version of pinning. So it's not for everyone. For those people that are mature enough and they have those internal certificate authorities already, it's a very good approach. So the next question is full certificate or something else. As we said, this is a full certificate. And you can pin to all of it. So you can include all the certificate in your application or multiple certificates. Or you can use just the public key. Or even better, you can use the SPKI structure, which is the subject public key information structure that includes the concrete public key and an algorithm identifier that says what this key is used for. It's a good thing to do it that way, and it's pretty standard nowadays. If you do the full certificate, as I said, this is very common. We see it all the time. The applications that just include their or PEM certificates inside the Android binary. It's very easy to do for developers because in order to retrieve the pins are the certificates. So you go to Mozilla, you right-click, you export to certificate, and then you have your pin. It doesn't need to be more complicated than that. And there are certain libraries and pinning implementations that only accept this form of pinning. So you don't have an alternative, really. However, certificates get rotated, and certificates get reissued. And even certificate authority certificates get rotated. But the public keys don't. So we're going to see in the next slide why that matters. A better approach is to pin just the public key. And this is a bit trickier because you need to use an utility or something to extract the SPKI structure from a certificate. But the most important point is this. It's flexible because it allows for key continuity. Key continuity is the process of rotating a certificate while keeping the public key the same. So when you have to rotate a certificate, it doesn't necessarily mean that you are going to rotate the public key of the server. The public key doesn't have an expiry date, the certificate has. So it's a very good approach, unless there are other reasons to do key rotation. But it's a good approach to keep the same public key, rotate the certificate, resign it, and your pin, if you pin just to the public key, is going to be the same. You don't need to change anything. And of course, you use the hash of the public key, not just the full public key. There are reasons for it to be anonymized. It's a good thing. We can discuss later if you want to know more details about that. It's getting traction. There are multiple open source libraries like OKHTTP that use the SPKI structure as the hash of the SPKI structure as a pin. And there's also, of course, the new HTTP public key pinning protocol, adopted by Chrome, basically, and pushed by Google people that uses that kind of pinning. So it's getting traction, and I think it's the way to go. There are some implications like the internal CA certificate that we talked about before. You cannot really do that if you just pin to the public key. And this is because in order to pin to an internal CA, you really need the full certificate because you are going to replace the trust anchor store of the system or your application. And to do that, you need the full certificate. So more operational things now. How do you handle a compromise? First of all, you have to handle compromises in two different layers. You have to handle the security layer. You have to assure the security of your users, and then you have to make sure that you manage the usability of your application after the compromise. So say that your host gets compromised, the host that you have pinned. What most organizations will do is to delete that server and reprovision the server and put a new public key in there. If you do that, all your users are going to stop like accessing your application because they are going to have the pins to the older key. Like managing their security is hard because revocation doesn't really work in those circumstances. Basically, revocation, first of all, the OSCP protocol is not really used by any major mobile operating system by default, and if it's used in fail open mode where it doesn't really work when there is an active man-in-the-middle attacker. So let's leave security of your users aside and try to manage the users to make sure they can access the application after compromise. And in order to do that, you have to have a fallback certificate or a backup certificate. So the idea there is that every time you provision a certificate to your host, you actually provision two certificates. One goes in production in the host, and the other stays offline in like an HSM or somewhere else in offline storage. So when you get compromised, you are going to swap, like you are going to get that certificate out of the offline storage and put it into your newly provisioned host. And at the same time, you will have the pins for both certificates in your application already. So your application will not see a loss of access. Like your users will continue to be able to access the application. And this is also mandated by this new HTTP public key pinning protocol. Another approach is to enforce application updates. So you have to know the versions of the application, the mobile application that your users are using, and try to stop them if they are using an older version of the application that you know has pins for compromised hosts in there. So there are multiple ways to do that. It may be that you detect that it is an older version and you show a screen where you say you need to update, please go and update and refuse access or go into a limited functionality mode. And then how do you handle rotation? Rotation is difficult, and as we said, we are going to see a lot of more often certificates being rotated. You have to keep track of everything, and that's not easy. You need to coordinate your different teams, basically the team that does certificates and the mobile developers. And that's not a very frictionless coordination. The idea is that you have a list somewhere of all the endpoints that are pinned and the versions of the applications that use those pins. And then you have a schedule, a calendar of all those pinned certificates when they expire. So you know that like in 2 months, this certificate is going to expire. In 3 months, this certificate is going to expire. So you have to create a schedule and try to issue new certificates before the expiration of the previous one so that there is time to include them in the application, to include the pins in the application. This is easier if you do scheduled application updates. So if once a month or once in 2 months, you know that you are going to have an update in the application. And at that point, like as part of the update process, there's a checklist that says, like, what about the pins? Like, do we need to add new pins? Do we need to remove new pins, older pins? So you make it part of the process. And of course, as we talked about, key continuity is also important. You have to, like, if you try to rotate the certificate without rotating the key, that is going to be better for everyone. Then, P failures. You can fail hard or you can fail soft. What do you do? The most secure approach is to fail hard and stop the connection from going on. This is a very common approach. It's the most secure, and it's not very flexible because pinning failures may happen at any point in the application, and your users may get a bad experience. They may see like a spinning wheel like all the time, or like your application may crash. But this is like the most secure one. There's an alternative that says that when pinning fails, then try to do the connection without pinning using normal HTTPS. And if that succeeds, then put the user like in a limited functionality mode until he updates or something like that. There are ways to manage it. It's very tricky though. It's not easy to get right. One last decision is how do you deploy the pins? As we said, the obvious approach is to preload them in the application. They become part of the application assets or even inside the code of the application. This is very common. This is very easy. It's not flexible at all because you need to keep track of all the versions. You need to keep track of all the revocations or of all the rotations. And there are windows of insecurity between compromise that happens and a rotation that happens and when the users update. It's not easy. There are alternatives like trust on first use. This is what happens in that HPKP protocol. The idea is that you connect to a server, you get the certificate, and then you use that certificate as a pin from like connections going forward. This is okay, but like it leaves an attack window from the time you like first have the application until you first connect, and then you have to manage expiry to see like when like you pin something, when is it going to expire? How often do you like renew that pin? It's not very easy to design. So this is a good approach, not for your most sensitive endpoints. So if you have other endpoints like analytics libraries or web traffic that pulls like JavaScript or whatever from everywhere, this may be a good approach. As you see, there are not right on wrong answers here. Like there are like complexities, and every solution has like its pros and cons. What we've seen lately is over-the-air provisioning. This is the idea is that you connect to a pin server and you download the pins. We have seen 2 or 3 applications doing that. It's not easy to design, but if you do it correctly, your deployments are very smooth because the application doesn't need to have anything except a pin of the pin server if you want to. But of course, you still have the complexity of having to manage the pins themselves and update that list. At least you do it centrally in a server, and instead of like having so many applications and so many versions with different sets of pins. Now let's go to bugs and flaws and bad designs. Basically, we have reviewed more than 20 or 30 applications that do pinning, most of them financial. And unfortunately, most of them have had various bugs. Number 1 on the list is chain validation. There are so many pinning implementations that as part of the pinning implementation, developers try to validate the chain of certificates themselves. This should never happen. X509 chain validation is a notoriously complex thing and should only be left to like network security professionals, developers, like people working on OpenSSL, which I know you may laugh like on OpenSSL, but they are very good still. You have to know that like all major chain validation implementations have had bugs in the past, and pretty much everyone that we have seen has had bugs. So please don't try to do it yourself. You can use the system's chain validation to do the validation, or you can use a third-party library like OpenSSL. We've seen this a lot of times. So you start with the idea of doing pinning, and you end up pinning 20 or 30 certificate authorities. Now, okay, like instead of trusting 300 of the operating system trust, you trust 20, the 20 most popular. I don't know, like it's a trade-off, I guess. One more thing you need to do is when you want to pin to 10 different endpoints, and you have each endpoint has different pins, you have to separate, like these pins are for this endpoint, and these pins are for this endpoint. And when you connect to an endpoint, you only load the pins for that domain, not for everything else. And we've seen that a lot of times. It shouldn't happen. Another thing we see all the time is forgetting half the connections. So if you've ever done like mobile development, or especially on Android, you know that you have like you create a class like a custom trust manager or something somewhere in the application that uses pinning, and then you try to use that for every connection. And we have seen so many applications using it for like the login process and not using it for everything else, or like not knowing what's going on. So try to centralize that, try to use it all the time, and there are ways to make it even more central and automatically hook all the connections using, like on iOS, you can use SwissLink to do that, and there are some APIs on Android that can help. Time of check, time of use. So this is an interesting bug. There are implementations out there that what happens is that you connect to an endpoint using pinning, and if it succeeds, you say like, hey, okay, everything is okay with this host, and you don't use pinning for this host from thereafter. Which is like weird, because an attacker can just man in the middle the connections that you're not using pinning and not try to intercept the other one. If you use caching, try to cache the end entity certificate, the leaf certificate, not the CA certificate, because if you cache the CA certificate, the whole implementation breaks down. And this is like an important bug, like the whole pinning implementation doesn't work. So the idea here is that you connect to an endpoint using pinning, and then you store that certificate, and you use it as a pin later on. But if you store the CA certificate, then nothing works. This is very interesting. If you use those APIs on Android or Java to do pinning, be really, really careful, because those APIs return the unvalidated chain of certificates. So the unvalidated chain of certificates is what the server sent to the client, not the validated chain that the client should have created. So if you look for pins in this one, in this chain that those APIs return, your pinning implementation is completely bypassable by an attacker. And there was, like I found like a bug in our OKHTTP library a few months ago, and they fixed it. I'm not going to go into very much detail into the advanced topics. It will be on the slides and the paper that's going to be published. Basically, there are multiple ways to do the implementation. There's like a whole taxonomy. The basic idea is that you can either do you can let the system do SSL validation and then check the pins, or you can load the custom trust anchor into the system and run the SSL validation itself. Like, we can go into details with anyone that wants after the talk. Handling the connections, you have to create your own library that is pinned and try to force all connections through that. And these are some APIs that can help do it automatically instead of trying to call this library all the time. They don't work for everything. For example, for web use, it's tricky to get to work, or for non-default implementations, networking stacks on Android. These are the real APIs that you're going to use if you attempt to implement pinning. Be careful on Android. There is improvement going on. There are multiple sets of APIs. Do not use the system's OpenSSL library. And actually, since a week ago, you cannot do that on Android. And these are some of the libraries that are interesting to be used for pinning. And there are others coming up. I'm going to publish something on like open source on OWASP that covers some more cases. Web views are notoriously hard to pin for both Android and iOS, but it is possible. It is possible. It has some complications. These are the APIs that you are going to use if you try to do web view pinning. The idea is that you are intercepting the request before it leaves the web view. You load it yourself. You go to the server, and you fetch the response, and you feed it back to the web view. It's a bit flaky, and it's blocking, but it works if you really want to. So I think, this is one thing. one last thing. Android introduced native support for pinning. Since Android Nougat, for those that don't know it, that's the name of the new Android version, Android 7, that is going to be released later this year. So you can use that, but it's going to be a good 2 years until most of your users are on that version. So you have to have fallbacks. So in summary, we saw that pinning is a headache. It's not very easy to manage. Those that really want to do it, they do it already. You can do it if you really must. It's best if you pin to the end entity or if you have an internal CA. Preloading the pins is probably still the best idea for the most sensitive hosts instead of using a over-the-air protocol or something like that is going to be complex until for your first implementation. Never do chain validation manually, and if you do anything with pinning, try to review your code a lot of times to make sure that it's correct, because there are so many things that can go wrong. So I think that will be all. If you have any questions. Yeah.
So on one slide you mentioned about hard reset and soft reset, and you mentioned in the soft reset there was a report mode. Can you?
So the question is about how do you handle pin failures, and if you do a hard fail or a soft fail. And in the soft fail, you can use the soft fail mode as a report mode. So the idea is that if pinning fails, then you do a normal HTTPS connection only to report the event to your implementation, so that you keep track of what is going on. Or you can, if you want to design it that way, you can actually implement pinning, but to start with, for the first few months, just run it on reporting mode, so that it doesn't really block if it fails, but allows connections to go through, but at the same time it gives you reports, so that you get a grip of how often those things fail. Anyone else? Yep. Yeah, so the question. So the question is, if you use soft fail, you may leak information. So yes, if you complete the connection in soft mode and you just ignore pinning and you do the connection anyway, then an attacker that has a CS certificate is going to intercept the connection. It's going to see what is happening. So it is a problem. It's still, it's not worse than not having pinning, right? So to start with, for your implementation, you can use that just for reporting, just to see what is going on. And if you want, you can limit the functionality of the attacker even on the client side. The client may be able to detect that, will be able to detect that pinning failed, and may not establish the most sensitive connections and establish something else. Any more questions? Yeah. So two approaches. I'm not sure I understood. Yes, so the question was that you can detect that the pinning mechanism has been compromised or something, and use an alternative way. That's why in the first slides, there was a slide about certificate pinning is not a control against local attackers. It's not a control that will ever be able to stop someone on the device that uses substrate or something to hook. So that pinning is not a control for that. So even if you detect that, then an attacker is going to detect something else. Like the way to raise the bar is actually to use like more obfuscation and use like other means of protecting the code and the binary instead of like using different implementations that may not be hooked. Like maybe the hooking that is going to happen like only targets one API, but then an attacker will just write another hook and hook your API, the API you are using. So what you want to do is create like a solution that stops hooking instead, not like move to a different API.
Any other questions? Thank you.
All right. Thank you.